Hello and welcome, dear friends. We continue to learn Unity, and in this video we'll talk about the canvas object. This is a theoretical video, so just watch and enjoy. The canvas is a component that controls how a group of UI elements will be rendered. This leads to the first rule. If a new UI element is created and no canvas exists, a new canvas will be created and the new UI element will be attached to that canvas as a child. So if I try to create UI game object, canvas will be created automatically. Let me do it. Clicking just once, we have created 3 objects. The UI object itself, the canvas, and the object of type event system. The event system object is responsible for ensuring that all child UI objects react to events like, for example, clicking on the UI object. If I disable the event system, then no UI objects that belong to the canvas will respond to clicking or all types of array casts. We can also add the canvas without creating the UI object. Let's do it. Right-click, find UI objects, and find the canvas object. Okay, good. Select the canvas in the hierarchy and go to the right side directly to its components. I will not cover direct transform components in this video. The reason is that this component cannot be changed under certain settings of the canvas. Let me just mention that this component is responsible for the position of the object, its size and rotation. We'll study this component very soon. Now let's talk about other components. Each canvas has several different possible render modes. The render mode can be set by using the render mode pop-up menu. Let's proceed with the screen space overlay. With this display mode, the canvas is drawn in screen space on top of everything else rendered in the scene. This means that all UI objects that belong to the canvas by default will be rendered on top of all other objects. We cannot change the size of the canvas, direct transform is not allowed to be modified. The object has strange coordinates, but we cannot change them either. The canvas has several child objects, one of them is background object, another one is the image of a mage, and 2 buttons. UI elements in the canvas are drawn in the same order they appear in the hierarchy. The first child is drawn first, the second child next, and so on. That's actually why we can see the mage image, since it was drawn later. If I replace the mage object, I will not be able to see it. I have also added a cube object. We can see it in the scene view. Let's check the game view, and we cannot see the cube object. The cube is not UI object, so its priority when rendering is less than the priority of the UI objects. If I change the size of the images, I will get the same result. We can only see the part of the cube. I guess it's not what we want to see. The pixel perfect property controls how pixels are displayed. I think it's better to show than trying to find the right words. Let me add one more image object, move it, and enlarge the image. We see that when the pixel perfect property is active, the image is aligned with edges of the pixels. Even if I try to move the object, Unity will move the object to the edge of the pixel. If the pixel perfect property is not active, then I will be able to place the image as I want. If you don't want to see any space between pixels, then it's worth activating this property. The sorting order helps when we have several canvases. If I open the Unity documentation, I will see the following description. What a detailed description. Well, if you have so many paid products, then you definitely shouldn't describe properties for free. Let's figure it out in action. Let me duplicate the canvas. I need to change something, for example, the color of a mage. Now, if I change the sorting order value, let it be equal to 2, for example, then the rendering priority will change. Now we see another canvas because its rendering priority is higher. You can play with numbers and display another canvas if you wish. The target display property is used when there is more than one display. Well, I haven't yet met such games, but maybe you have. And the last property is used for more complex special effects. By default, Unity uses standard shaders. These are the optional additional parameters of shaders to be copied. Sometimes also I use these parameters when I create objects of TextMesh prototype. Okay, let's go back to render modes. The screen space camera mode looks like the previous one, however, it is significantly different. It is rendered by a specific camera in the scene. As you can see, the canvas component requires a camera. Let me drag the camera into the field. This will allow camera-specific settings to be applied to screen space. In this mode, the canvas will also fill the camera's viewport automatically and will resize automatically if the camera's viewport settings will be changed. And direct transform is also being driven entirely by the canvas. In this case, we have different rendering order. When the screen space overlay property is active, we cannot put anything between the camera and the canvas. At first glance, nothing much has changed. However, some things have changed. For example, in this case, we can configure the distance between the camera and the canvas. The default distance is equal to 100. I will switch to 3D mode and see where the camera is. Here it is. If I move the camera, the canvas will move with the camera. The same will happen if I rotate the camera. If I change the distance to 50, then the camera will move closer to the canvas. But that's not the only difference. In this case, I can add an object between the camera and the canvas so that we can adjust the rendering priority. I will switch to 2D mode. Let me resize the cube a bit and configure its position. Okay, now the image is closer to the canvas, but it is further from the camera. Now we see that the cube overlays the image object since it is closer to the camera. Let me move the image object. I will change the position of the cube object one more time, let it be further from the camera, and let's see what has changed. Now we can see the image object. The closer an object gets to the camera, the higher priority it gets for the camera. However, among UI objects, this rule still works according to the location in the hierarchy. Let me show it moving the images. Now the blue one is closer to the camera, but is higher in the hierarchy. In this case, I will see the yellow image since it is below the blue one in the hierarchy. When the screen space camera mode is active, we also can set the rendering priority using the sorting layer property. Let me activate the second canvas one more time. Change the render mode to screen space camera and drag the camera. Let the order in layer property be equal to 1, same as the value of the first canvas property. Okay, let's add a sorting layer using the add sorting layer function. We'll talk about layers in detail later, this is a very important topic. Now let me just show how the sorting layer property works. Okay, here we have only one layer to be sorted. Actually, this means that there is no sorting so far. Let me add one more. To name the layer, I will use one of the built-in layers. Let it be UI layer. It is a built-in layer. You can see it if you open the layers pop-up menu. The logic here is quite simple. The higher the layer is, the more priority it has when rendering. Now the default layer has a higher priority. Select the canvas and let me change the sorting layers. Let's see what has changed. Okay, the canvas with the default layer is rendered above the canvas with the UI layer. This is how it works. Let's proceed with the render modes. The world space render mode has more freedom, it has less restrictions. The first thing to note about a canvas in world space mode is that the canvas no longer derives direct transform, and the canvas can be set anywhere in world space. In this mode, the canvas is going to be treated as a regular game object. You can rotate, scale and move the canvas and position it wherever you want. Also, other game objects in the scene can pass behind the canvas, through it or in front of it. We're not going to use this mode in our game, but please be familiar with that option also. Let me mention one more time, in this mode we can manage the canvas size ourselves, and it can be very useful if we use more than one canvas in the scene. Click on the File tab, Build Settings. I want to add resolutions that are popular for Android. Here you can choose one of the target platforms. It should be the most promising in terms of monetizing your project. You may choose whatever you want, depending on your goals. I will switch to the Android platform. To do this, I will select the Android menu item and click on the Switch Platform button. I need to wait a bit. This project settings window is also used to switch between scenes, but we'll talk about this later. Well, the target platform has been changed. Let's see what the default screen resolutions are. Open the game view and we can see available screen resolutions. Of course, this is not the only thing that has been changed, but it is important for now to add resolutions for Android. Well, I could do it manually by clicking on the plus icon. Here it is better to choose the aspect ratio and set the ratio I need. But this is not necessary because we already have everything we need to develop our game. Let me also change the background color of the camera to better display changes in the aspect ratio. Okay, let's get started. We have started talking about components attached to the object of type canvas. Another interesting component of the canvas is the canvas scaler. In screen space overlay mode or screen space camera mode, we can set the value to the UI scale property. If the render mode is world space, we cannot change the UI scale property. This property determines how UI elements in the canvas are scaled. There are three options. The first one is constant pixels size. This property makes UI elements retain the same size in pixels regardless of the screen resolution. On the one hand, this is very good since we don't lose the quality of the sprite. On the other hand, there is one problem. If I change the resolution and if Unity tries to render the same size of the UI objects, then we will get something very strange. Of course, the image quality is better, but it will be difficult to play this game on different devices. This property is used if you need to preserve the quality of a particular UI object, but usually we don't care about this. Much more useful is scaling with screen size. The first property here is the reference resolution. This is the reference resolution of the canvas we are going to work with. The reference resolution means that when you change the screen resolution, the canvas will change by the ratio between x and y values. X for the x-axis, y for the y-axis. In our case, this ratio will be the ratio of 90/20 to 1080. But there are several nuances. As usual, all problems are in detail. The rule for using proportions is determined by the screen match mode property. By default, we have a method that matches width or height. Now the value of this property is equal to 0. What does this 0 mean? This means that Unity takes the width value as the reference, that is the x value, and the height is recalculated depending on the ratio of x to y. It's better to see in the portrait resolution. As you can see, the height of the canvas is recalculated and the height should be almost twice the width. More precisely, the height is greater than the width by this ratio. You can check this if you look at the width and height of the canvas. If I move the slider to 1, then we get the opposite situation. The height of the resolution will be taken as a reference and the width will be recalculated. What proportion should you choose? There is no single answer to this question. It all depends on how the objects are located and what target screen sizes will be the main ones for your game. Developers often choose a ratio of 0.5, but this is not always the best solution. If the game is in a landscape resolution, then it's better to take the width as the reference. We'll do this for our game. Now we can see that buttons and images moved chaotically. For example, the distance between buttons and canvas edges becomes bigger or smaller. Often this leads to problems. For example, the button may move off screen, or one UI object may overlap with another UI object, or the UI object may be stretched too much, like for example the mage object, it got bigger. We'll talk about this a bit later, but for now let's continue with the properties of the canvas object. The reference pixels per unit property helps to calculate the pixel density. The fact is that each sprite has the pixels per unit property, which means how many pixels will be in one unit. The unit here is the distance used in Unity as a reference. We know standards like meters, for example. Unity has its reference units. This unit is called unit. And that's all we can say about this. So for sprites that have the same pixels per unit as the reference pixels per unit in the canvas, the pixel density will be 1:1. If not, the pixel density will be recalculated according to the ratio between two properties. It's hard to visualize this, but we believe it's true. The last UI scale mode looks like the constant pixels size property. The difference is that when a canvas has the UI scale mode set to constant physical size, every item in the UI will maintain its original physical size, and this will be done regardless of the size of the screen. If we use, for example, centimeters, then the size of UI items will be constant in centimeters. This option is used rarely for specific tasks. Maybe it's used to calculate the salary of game developers. No matter how much you do, the wage remains constant. I haven't met this kind of task yet, therefore I will not dive into this topic. Okay, let's continue with the screen match modes instead of calculating centimeters. The expand method expands the canvas area either horizontally or vertically. Unity takes the shortest side of a canvas as a constant value and widens the longer side. That's actually why this method is called expand. In our case, the shortest side is the height, so that the height will be as many times the width as x is greater than y. In this case, the result will be the same as if we choose the scale with screen size mode and set 0 to the match property. To check this, just select the canvas object. New values of the width and height have the same ratio. The shrink method makes the opposite. It takes the longest side of the canvas as a constant value and widens the shorter side. So the size of the canvas will never be smaller than the longest side. I hope it's clear. Let's see what the graphic raycaster is. The graphic raycaster looks at all graphics on the canvas and determines if any of them have been hit or clicked. The ignore reversed graphics is used when, for example, the button is somehow reversed and you still try to click on it. I would like to know who can do this, but let me show you how it works. The button is working as expected, and if I click on it, I will see the message. But if I rotate the button and try to click on it, the button will not respond to the click, since the ignore reverse graphics property is true. If it is false, I will see the message again. Let me click on the button one more time. Good. The blocking objects property defines what kind of objects will block raycasts. Let me select the 3D value and move the cube so that it covers the button. Now if I try to click on the button, I will not see the message. The cube blocks the button. If I select None again, I will see the message. This property is rarely used. There are many other properties to manage all types of raycasts. However, you can also try to use it if you need. And the last property is the blocking mask property. It defines type of objects that will block graphic raycasts. However, this time this group of objects can be defined by the layers. This property only works better by complementing the blocking objects property value. For example, let the cube block all raycasts again. Let me set 3D value to the blocking objects property. The cube has the default layer, therefore I will exclude this layer from the objects that can block raycasts. Now if I try to click on the cube object, it will not block the button, while all other 3D objects will continue to block the raycasts. Well, this is where I will finish talking about canvas components. It's time to talk about another important topic. Now if I change the screen resolution, then UI objects will move and they will move chaotically. I believe this strange behavior should be fixed. Objects run in different directions. As politicians and human rights, they rarely go in the same direction. However, Unity is not a real world. Here, at least, we may try to fix this. We can try to create a kind of an anchor to restrict the UI object's movement. Okay, let's look at the rect transform component one more time. Click on the icon in the top left, and here we can set the anchor. The anchor point is currently at the center middle. You can also see it in the scene view. Unity will try to keep the button position as close to the center as possible when the resolution is being changed. For example, I want the button to always be in the upper corner of the screen. I can set the anchor point to the middle right, and the second button, let's say, will be anchored to the top right, just to see the difference. Now if I change the resolution, I will see that the first button will take a position in the upper right corner of the canvas. The second button will fly far up, but will be within the boundaries defined by the anchor point. We can do the same experiment with images of mages. Let me move and resize them and set anchors again just to see the difference. Let the first mage be stretched. I guess we'll see something weird. And the second mage will be anchored to the right bottom. Let me change the resolution. Okay, it looks funny, but the UI objects follow the anchors we have set. Well, there are many more tricks related to anchors, but I hope we are ready to apply all of these to the game.